Okay, shall we start now? Are you ready? Okay.
Yeah, let's start.
Hi everyone, and a very warm welcome to Huawei Student Developer events. My name is Badr, and I will be your host this morning. I'm incredibly excited to be hosting our HSD event in France. This morning we've got some exciting things to share with you, so let's crack straight on. HSD is a global program open to undergraduate and postgraduate students with an interest in growing as developers. HSD offers students the opportunity to expand their scope of knowledge in a dynamic peer-to-peer learning environment through enriching training courses and activities. We're going to be covering a few topics today. We're going to be introducing Harmony OS and wearables, and talking with Minky and Pan. Minky, one of our Huawei developer advocates and technical engineer. Mohammed Simsek from the Huawei Europe Developer Support Team be hosting the demo for student developers like you to experience Huawei's open capabilities, and where our experts can provide support for you to leverage the full range of HMS services. Before I hand over, I will, if you have any questions, please write them in the comment box to the side, and we'll try and answer them all at the end. Let me hand over to Minky, and I hope you all enjoy the event.
Hey, yeah, thanks for the introduction and hand over, Watson. So let me start my presentation about Harmony OS and wearables. So let me share my screen. Can you see on my screen?
Yes.
Okay. Sweet. Cool. So just use the laser pointer. So yeah, welcome to our today's seminar about Harmony OS and wearables. My name is Minkan Pan. You can just call me Minky. I'm a Huawei employee since 2020. And the agenda today is about Harmony OS, and then introduction to wearables, Harmony OS development framework, and what you can develop on wearables, and then we have a Q&A session, and at the end we still have a online demo session with my colleague Mohammed Simsek, who is also here. So let me introduce you and explain you about Harmony OS. So what is Harmony OS and why? Before I explain this, I want to show you our current situation in the market. So we all know that the smartphone market is getting more and more saturated since everybody is having a smartphone, and you only have maximum one smartphone, right, per person. But the number of IoT devices, they are rising and rising. Imagine the smart homes you maybe have at home, like Amazon, Google, and all the vendors who are out there. So the average amount of IoT devices per person is rising. And the situation is, you may already know that we have tons of operation systems out there currently. We have iOS, Android, and Wear OS, TV OS, Chrome OS, from all various kind of IoT devices. And the problem is very fragmented. So you may know that you have to, maybe you bought a smart lamp and now you have to download extra an app for that. You have a microwave, a smart microwave. You have also downloaded another vendor app for that. So you have to download tons of apps, and they are not interoperable with each other because they're coming from other vendors. They have different operation systems. So you have to set up one by one, and you have all these apps. And this could be really complex for the user and difficult to maintain. So that's why Huawei they introduced HarmonyOS. So they developed this operation system with the idea that this operation system can run on all IoT devices. So from low hardware specification to high-end hardwares like smartphones. And with this one OS, all IoT devices and smartphones, so every hardwares out there could be connected. So you have to only to deal with one operation systems and not with different various operation systems. So HarmonyOS is an open source, multi-kernel based distributed OS, and yeah, designed for IoT ecosystem. So the design principles, like I mentioned a bit before, so it's made for IoT devices. It's a multi-kernel design, so it's designed also for low hardware CPUs and so on. So even a lamp could run in theory HarmonyOS. And it's unite different smart devices into a single super device, and every device should share their resources, and it should enable a seamless interaction among all the devices. And the HarmonyOS code is open source, so the community everyone can contribute to the source code and see the implementation. And yeah, this is designed for open IoT ecosystem. So it's like Android operation systems are also open source and designed for all smartphones, and every vendor can take it, but it's just for smartphones. And in case of HarmonyOS, it's designed really for all devices, from IoT devices to smartphones. That's why it's an open ecosystem. Let me show you some use case samples, what we could do with HarmonyOS. Imagine you have at home a treadmill. You are training every day, running on this treadmill, and then you are carrying a smartwatch, and at the same time, you have your smartphone. With HarmonyOS, you can see in this picture that imagine you are running on a treadmill and you are carrying a smartwatch, and at the same time you are calling your friends or colleagues, video calling your friend or colleagues, and you can see that if you use HarmonyOS, all these devices are connected. So you can see the heart rate, which is coming from the smartwatch, since smartwatch has a sensor to measure heart rate while you are running. And at the same time, you are seeing the picture of your friend, who are your colleague or your trainer. And also the treadmill is measuring your speed and your distance. So they are all seamlessly connected together. Another samples are like, imagine you just have a smart microwave, and you can just connect your phone with the microwave to control it without downloading an extra app. You can just tap it and they are connected. Or you are sitting at home, you just came back home, you was watching a video in the public transport, and then you came home, and then you want to continue watch this video on the big TV. Since they're all connected, you can just project your video to the large TV without turning on the TV and find the video and forward to the part where I've stopped on the phone. So this was all the use cases. Now let me explain a bit about the history of HarmonyOS. So the HarmonyOS was an in-house developed operation system. It was based on Linux. And it was closed source initially, but then we separated, and the basic capabilities we open atom This is the front like Apache. You can imagine like this. And on the other side, for our in-house HarmonyOS, which is closed source, we added also Android open source project to HarmonyOS. So this is just a rough history about HarmonyOS. Why I'm explaining this? Why I explain this is because now we have our commercial Huawei devices like phone, tablet, smartwatch, and you may see if you grab one of them, you can see much similarities to Android. That's because we added the Android open source project. We merged them together with HarmonyOS, so you can see a rough architecture layer. So we have the Linux kernel below. Then we have the Android open source project. Then the HarmonyOS part here, we have an adaptation layer so they can talk with each other. And then we have the application layer. So it's like an Android plus. Yeah. And for the Open Harmony part, so our general vision, our long run vision is this 1 plus 8 plus n. So what does it stand for? So the 1 is your smartphone. Your smartphone should be the master controller or the super device. And the 8 devices are the other Huawei commercial devices like PC, earphone, auto, speaker, watch. And they are running our commercial HarmonyOS. And the N stands for all other IoT devices. All other vendors, they can take the open source Harmony OS and adapt them with their hardware. And then all of them should be connected with each other. So now you heard HarmonyOS and Open Harmony, and this might be a bit confusing for the end consumer. That's why, for commercial simplicity, we say only Harmony OS. Yeah. So this was the introduction to HarmonyOS. Now I will go to the wearables, since they are all running our HarmonyOS. That's why I explained the HarmonyOS part. So you may know, so maybe you're also wearing one or you bought one from Huawei. We have many smartwatches covering different styles and cases from so full range from professional for sports and classic style, fashion, care, like for kids, or blood pressure, like the Watch D for older people, and smart, yeah. So where you can do a lot of things. We are very strong in the overseas market. So out of China, we are ranked number 3 in Q1 2022. We are capturing 30%, 14% of the overseas market. So we may still not be as good as Apple, but we are quite good already. And if it comes to the development, we differentiate between light and smart wearables. So why is that important for us? Because they have different hardware specifications. So a light wearable is running a light version of Open Harmony. It has a very low RAM and some I/O features, but a very, very strong battery. And the smart wearables, they are smart, so they have a huge RAM and tons of hardware features. They have Wi-Fi and LTE, NFC, and so on. But it's important to make this differentiation for development. So now let me go to HarmonyOS development framework. So if you want to develop apps on HarmonyOS wearables, we have IDE, a dedicated IDE for that. We call it Dev Eco Studio. So Dev Eco Studio is designed for HarmonyOS development generally. So not just for wearables, also for TVs and smartphones and all other devices, IoT devices who are running OpenHarmony. It's based on IntelliJ. So if you're familiar with IntelliJ, then you will get very fast used to it. So all the shortcuts and so on features are very similar. It's just like for the Android developers among us, it's like Android Studio, which is also based on IntelliJ. And the development language we are using. So for light wearable, we are using JavaScript and HTML. This HTML stands for HarmonyOS Markup Language, but it's very similar to HTML for layouting. So it's like a web development. So if you're a front-end developer, you can easily get started with it. And for smart wearables, we have more choices. So we can use JavaScript or HTML for layout. And we can also use Java and XML, which is actually very similar to Android. So if you're an Android developer, you can also get easily started with the smart wearable development. And we can, so if you're hardcore, you can use native C++ to do everything. Yeah. And you might ask, okay, this is, the languages are old school already, Java, JavaScript, this is over 20 years old, so it's maybe not that fancy anymore. And but in the development, we want fancy language, we want new stuff, we want hot shit. That's why also we know this, and that's why we introduced a new programming language, which is just dedicated for HarmonyOS. And we develop a new framework for HarmonyOS, which we call ArcUI. This is a modern declarative user interface framework. Just like, if you look today in the industrial coding world, and many frameworks come with a declarative user interface approach. It's like Android Jetpack Compose, iOS SwiftUI, React Native or React in the front end, Flutter for cross platforms. So we introduced ArcUI and with the language extended TypeScript. So it's a framework-based TypeScript, and it's designed for very quick development and declarative user interfaces. So you can see a comparison between left and right. On the left side, you can see that if you develop such an app with the old school Android programming language like Java and XML, you will take tons of code here. But with the new language, it's reduced a lot of boilerplate code. Yeah. And on the right side, you can also see we have a really good preview and live loading, live reloading, and you can preview various devices at once. And you can really what this shows is we can really quick bootstrap some applications. It's just like as you would develop a front-end application, but on a mobile device or on an IoT device. So let's maybe talk about what we can develop on wearables. So what we can do. So we differentiate between light wearables and smart wearables. So on a light wearable, we have a small RAM. We have only like 32 to 64 kilobyte for an app. So we don't have much RAM here also. So therefore we can't do much. So the applications we can do are small, and it's just mainly used as a companion for smartphones. And it's just a smart extensions to the user experience on a smartphone. It's mainly to exchange data between phone and wearables via a Huawei Wear engine. Just for example, you use the GPS or body sensors of the watch to transfer them to your smartphone. And examples are like showing maneuver instructions on wearables, doing map navigation on phones, since you don't have to take out your phone every time. You can just the wearables will tell you where to navigate. On the other side, on smart wearables, you can do a lot more, since it has a huge RAM and very good hardware specs. And you can do the same like wearables, like data exchange, but you can also deliver a standalone user experience without to rely on the smartphone. So it has its own Wi-Fi, LTE, so it has its own internet. It can also connect to internet itself. And we have a wide range of IOs like Wi-Fi, NFC, Bluetooth, GPS, media, so like microphone, a sound speaker, file system, security. So it's as mighty as Android actually. And it runs our Huawei mobile services. So our counterpart to Google mobile services. And you can do a lot of things like just standalone map navigation. You can like do some map applications on a smartwatch without relying on a phone. You can just stream a music and write some chat applications and more. So we have many success cases with partners already. So on the left side, you can see this is Nuki. Nuki is they are developing smart locks with watches. So you can just in this case, you can see you can just open a door or lock a door with the smartwatch. So you don't need to carry your key anymore. In the middle, we have Urban Air application, which shows you all the scooters or rented cars or bikes and the distance, and navigates you to this bike or car or scooter. On the right side, we have iTranslate, so you can just use the smart watch to translate any languages and use it as a dictionary, as a fast and convenient dictionary without taking out your phone. And on the light wearable part, we have also success cases with great partners, huge partners like 50 Workouts. It's a workout app where you can track your heart rate and on the watch and send the data to the phone. We have on the right side HUAWEI sensors. I'm sure many of you know them. It's a vendor for smart lamps, and in this case you can turn on, turn off the smart lamps with your smartwatch, so you don't need to go to the switches. And also you can adjust light and colors and so on. And also another case is Camera Opus, who just released their app on smartwatch and lightwatch. So it's an app which previews the camera, so you can it's a really convenient app if you want to make a selfie and so on. You don't need to take out your camera. You don't need to click on your camera. You can just click on the smartwatch or on the lightwatch, and you can preview on the lightwatch and smartwatch. So it's implemented for both. Yeah, so these are my success case sharings, and now I'm coming to my end, so of my part. We have prepared 2 demo codes. We have a full open source. We have a wearable sensor and live scores. You can scan the QR code if you want now and mark them. And if you're interested in development, then you can just check out the source code and see what's inside and how it's implemented. And generally, on the bottom side, we have our official website about HarmonyOS. And if you are interested, if you want to contact any of us, then please just write our official contact email, HarmonyOS bd@huawei.com, and some professional guy will be in touch with you. And so if you have question now, we can have a Q&A session now, and then we will go to an online demo show with my colleague Mohammed Simsek. So we can go to the demo show now and make the Q&A session later, or if you have questions now, you can ask them now.
Okay, thank you, Minky. The HarmonyOS sounds very impressive. So maybe we can move on to the session with Mohammed, showcase, demo showcase. Okay.
Yeah. Okay, then let's move to the demo showcase. And we'll forward to my colleague Mohammed Simsek, and he will show you some of what he has done and what also a bit about the code, how it is written, and about the IDE and framework. So Mohammed, would you like to share your screen, please?
So I will share my screen in that case. Are you able to see it now?
Yes.
Okay, great. So we have developed a small demo to showcase how you can make use of some of the sensors on a Huawei wearable and how you can exchange data between the wearable app and an Android phone app using the Wear engine. So let's get started with the wearable app. So here you can see I have a project with two modules, one for light wearables and one for wearables. We'll start by examining the module for the wearables because it has a few more features and it's easier to see what's happening. So we have developed the app with JavaScript, HTML, and CSS. So one important file is the config.json file. This is basically our manifest where we define which pages we are using. So we have 4 pages, and this is also where we define the permissions. So for example, in order to make use of the heart rate sensor, we need to specifically request permission from the user, and that's why we define the permission here. So when the app gets opened, it starts on the first page, which is of course the index page. And we can see that HTML, it's language similar to HTML, where we can define elements with tags. So we have a list, and under the list we have like 4 list items, which only consist of a button. And I would like to show it. So we can click. I have to connect my watch. So you can see my watch right here. It's a Huawei Watch 3. In order to connect it, I have to turn on developer options by going to About and clicking the build number a number of times. And then I'm actually able to enable wireless debugging. So debugging over Wi-Fi. So with using this IP address, I can connect my watch to the IDE using HTC, which is the name of our debug bridge. And now I will be able to actually build and run the app. Now it's sending the HAP file, which it will install, and then it will launch. So we can see that we have a list with 4 elements, with 4 items in it. And all the items consist of buttons as we expected. And the way we define how these items look is with CSS. So for example, we have defined a button class for the button elements. we go here, we see that we have defined that the width should be 80% of the parent layout. This is probably quite similar as you would expect. But we can also see like that when we click on a button, it changes the background color to indicate the click effect, and we can actually customize this effect by making use of pseudo classes. So we can say that when the button is in the active state, the background color should be something else, like for example purple. We then rerun this, which can take a moment. The CSS that will be used when the button is clicked will actually be different, and the background color will be purple. So using this, we can like define different styles for individual stages of elements. We can see Gradle build is running, and then it will. So when we build an app, what it does is actually it creates this HAP file, which is the file that we will install. So it's similar to the APK in the Android world. So after it's done building it, it sends it to the phone using Wi-Fi, and afterwards it installs the app and launches it. Let's take a moment. Yeah, now it's deploying the app. And it's launched. So now if we click on a button, we can see that in the active state, the background color is purple. And it applies to all the buttons because we have changed the class, which we have applied to all the buttons. So, and then there is also the JavaScript part. So every page consists of 3 parts: HTML for the layout, CSS for the styling, and JavaScript for the logic. So you can see here that I have imported the Wear engine, which is used to communicate between the watch and the phone. And the Wear engine, it's actually here. So this is the library basically that we are using. And we can, so when we want to make use of the Wear engine, we actually have to create a Huawei developer account, log in with it, and then head over to this Wear engine section and apply for the Wear engine. You can see that I have already applied for it for the test app that we are using right now. But if you want to play around with it, you have to go through this process where, where some colleagues of us will determine to enable the features or not. So if you are only developing for smartwatches, so the watch 3, you can select this one. If you're only focused on light wearables, you can select this one. But if you want to support both types of wearables, you have to select all need support. And then you can describe what the function is going to be for the wearable app and which features you want. Most of the time we'll just use basic device information and message notification in order to send data between the watch app and the wearable app and the Android app. So after going through that, you will be able to download the Huawei Wear engine, which you can also find in the documentation. So if you head over to SDKs, you will find a different SDK for smart wearables and a different one for light wearables. So you will just click on it to download it, and then you can import it to your project like this. And you will be able to start using it in your JS files. So what we have done is on the onInit function. So this is the first function that gets run in the life cycle of a page. So when a page is created, it will run on init, and when the page is destroyed, when it's left, it will run on destroy. So we can do build up and breakdown operations. So when the page is created, we create a P2P client so we can communicate with the watch. And we set the peer package name peer fingerprint. And the reason we do this is so that other apps are not able to try to manipulate our apps on the other device. So if you have a watch app with some which stores some secret information, and you have an Android app that requests this information, then of course it should not be possible for developers of other Android apps to request this information. And the way we prevent that is by enforcing you to set the fingerprint of the Android app. So these two pieces of information is about our Android app. So in the Android app that wants to communicate with our watch app needs to have this package name, and it needs to be signed with a signing key whose fingerprint corresponds to this. Otherwise, the communication will not be facilitated. Right. And now as we see that on the on-click event of the buttons, we define which functions should be run. So for example, when the punch button gets clicked, we want to run the on-punch button click. And what this function does, it uses the router to start a new page. So we can see that in action. When we click on it, we are navigated to a new page. And so the page that we are navigated to is the punch page. So this page. And what I have done in this page is I have made use of the accelerometer function to determine how fast someone is punching. So we can head over to our documentation for Harmony OS, to the sensors page for the wearables, and we can see that which sensors are available for us on a wearable. So on the right-hand side, we can see that there are quite a lot of wearables available. So we make use of the subscribe accelerometer function, and so we can pass on a couple of different parameters to make use of this the sensor. So we can define how frequently we want to get an update for the values, and what to do when the subscription succeeds. So which function we want to run. So what I have done here is I have defined that I want to get frequent updates of the accelerometer, and then I have defined a function to make use of the data. So the data that is returned is the acceleration data on the 3-axis x, y, z. And using this, I got the square root of the sum of the squares of each axis, and then that way I basically defined this. That way I calculated how fast the user has punched. So if I click on Start Punch, wait for the countdown, and then punch, you can see that uses the accelerometer data to determine how fast or how hard I have punched. So this can be used to build some, little fun game. So that's one thing to show. And you can see on the on-destroy function, I make sure to unsubscribe also from the accelerometer. And then there's another page. So when the user on the index page clicks on the heart button, on the heart rate button, he is guided to the heart rate page. So you can see, because the user has to agree to the usage of the heart rate sensor, he needs to specifically allow it. So on this page, what I have done is I've just defined 2 text elements, one for showing the time at the top, just as a nice little feature, and the other one is just for showing the heart rate. And so in order to get the time, I just used the new date function that we know in JavaScript, and got the time like that. And I call this function every second to update the time. And the more interesting part is the subscribe heart rate. So this is yet another sensor that is available on smartwatches. We can also find it here, subscribe heart rate. We see we need this permission, which we had already defined in the config.json, and then we will get the heart rate as a result. In order to also show the usage of the Wear engine, I have actually also developed an Android app, and I will be sending this data to the Android app. So when the heart rate is obtained, we call the send message function with the heart rate. what send message function does, it takes this value, it puts it into a JSON key value pair. It builds the message, and then it uses the P2P client to send the message. And we can yet again see that we are setting the peer package name and the peer fingerprint. So let's have a look at the Android app. So on the Android app, it's the Android app, and we can see that here we are also defining the peer package name and peer fingerprint. So this is the package name of our Harmony OS wearable app, and the signature that corresponds to the signing key used to sign our wearable app. So let's also show phone app. So this is our phone app. This one. So let's build it. So we see that when the device is found on the phone app, and you can see that we are also able to like get the information of the connected watch, so we know it's all right. That's the wrong one. So we are actually able to connect different watches, and the way we connect the watches is actually through the Huawei Health app. I actually have two different watches, and the one that's connected right now is the GT3, which is the live wearable, but I should of course connect the Watch 3 instead. It can take a moment. Right. Let's relaunch this app. Right. So now we can see that that we are connected to the correct watch, the Huawei Watch 3. And the way we check that is, let's see. Right. So when we obtain the devices by calling device client.bonded devices from the Wear engine, we are able to get the name of the watch and a number of different pieces of information are also available, like the model, etc. And see, we can get the capabilities, the UID, etc. But we are getting the name, and that's how we can show which watch we are connected to. And we are also registering a receiver for this device. So this is our device that we are registering a receiver for, and we are also tell which callback to call when the message is received. So here we define our callback on received message. So we get a message, and we can actually exchange both messages consisting of text and also send files across the two devices. So if we receive a message of type data, so just text, then we try to parse the JSON that we received, and if it contains a heart rate object, then we actually set the heart rate text field to this value. So you can see that on the wearable side, we are sending this data right here with the P2P client.send message. And on the Android side, we are receiving this data. And so you can see that here we are using the heart rate sensor of the wearable to obtain the heart rate, and we are sending it to the phone. And my watch turned off for a moment. So your watch actually needs to be connected to Wi-Fi in order for the screen sharing to work. And because my screen turned off, my screen sharing also stopped. But yeah, so we can see that the heart rate that is collected by the heart rate sensor of the watch is also sent over to the Android app. And so you can see that this way we can display the same data. And you could decide what you want to do with this data. For example, you could store it in the Android app. You could graph it nicely visually. Yeah, or do some kind of competition between different users. It's the possibilities are really endless. And one other function is the ping function. So we can send a ping using the Wear engine from the watch to the phone, also from the phone to the watch, in order to check if our app is actually installed or not. And when we send a ping from the phone to the watch, we are actually also able to launch our watch app. So you can see it being done here. So we call the P2P client.ping function, and the result that is returned, we put on the screen as a toast. So we can see our app is closed, but when we ping the watch app from the phone app, it actually gets launched, and we see status 202, which means the app is now running. So that's one cool thing we can do. This actually works out of the box for light wearables, but for wearables, we need to name the main ability, rename it as HUAWEI main ability, otherwise the app will not be launched. And there's like one small tweak that you need to do, and that's not really well documented. And then for the last feature, so I also have a screen with some other sensor data that I collect. So we can also have a look at that. It's just displaying 3 pieces of data. And the way we are, by the way, the way we are displaying data is by data binding. So you can see that I have here like a notation with 2 curly braces, and I write a variable name in it. So, and the where we define these variables is actually in the JS file. So we have a data object here with light put into it. And so when I update this value, it will also reflect on the layout on the screen. So what we are doing is we are just subscribing to 3 different sensors: barometer, light sensor, and on-body state. So we can see the light sensor. What the light sensor does, it expresses in lux how much light is hitting the watch. So if so right now you can see a low value, but if I use the torch of my phone and hold it to the watch, you can see it increases dramatically. If I hold my hand over the watch screen so that almost no light hits it, the value decreases. So maybe you could use this to automatically adjust the brightness of the screen, or if I don't know if you can think of some other way of using it. Then there's the barometer, which expresses in Pascal how much pressure there is right now. And the last one is the on-body state. So this fun. The watch actually knows if a user is wearing it or not. So if I take off my watch like this, it turns to false. So that's one neat little thing. If I put it back on, it turns back to true. So that's basically what there's to show. And one other thing is, like, when at the beginning we had, for example, made some changes to CSS, and you don't actually need to wait all the way for it to rebuild and send the app to the watch. We can actually make use of the previewer to see the results quickly within the IDE. So for that, I clicked on the preview button, and now we are waiting for the IDE to compile the resources and show us the result in the previewer. Right, so we can see it here. We can pretty much interact with the app. This like an emulator, but a little bit lighter. So if we make a change here for the background color to be red, we can immediately see the result. So it also shows some fake sensor data, things like that. So you can use the previewer to really debug, well, to see the results of your app basically without a real device. So that is everything on the wearable side. And then I also want to mention some nuances if you want to also support light wearables. So wearables and light wearables, they can both be developed with JS, HTML, and CSS. However, the light wearables, they are a little bit more limited, and we can see that in the documentation. So for example, here we have in the reference section, we have documentation for tablets, smartphones, smart TVs, and wearables, but we have separate documentation for light wearables. And we can actually see that the number of APIs, for example, that are available for light wearables are quite smaller in number. And also the number of components that we can use, they are smaller in number. So theoretically, maybe you could have one module that could both run on wearables and light wearables, but this is quite limiting and quite difficult to do. So what we actually suggest is to just, if you want to support light wearables also, is to just create a new module specifically for light wearables, and then just give it a name and things like that. Give it the same package name, and I've already done that. So that is why there is an entry_light module right here. After doing that, I've basically copy-pasted the pages that existed for the wearable, because most of the things we can actually reuse, but we have to actually go through it and see what we cannot reuse. So for example, in the index elements, we can see that while for the wearables, we were using a button element. For the light wearable, there's actually no button element. So instead of the button element, we're using the input element and passing it the type of button. The result is pretty much the same, but you just have to keep it in mind. We can check the documentation, and we can see that there's really no button element for light wearables, so we have to use the input element instead. And so we can also really, the documentation is quite good in that we can see which elements we can pass to, which attributes we can pass to each element and how they affect the element. Right. And another thing is that the APIs are also more limited. So we could see a lot of sensors for the wearable, but on the light wearable, the number of sensors are quite fewer in number. So for example, there is no accelerometer. So because of that, I had to remove this punch screen because the functionality was simply not available. So it's you have to make the app a little bit smaller and adapt it specifically for the light wearable. So maybe you will have an app with full functionality for wearables, but for light wearables, you will have to remove some of the functionality. Also on the sensors page, there's no light sensor on the light wearables, so we have also removed that one, and we are only getting the body state and the barometer. But for example, the heart rate sensor, this page is exactly the same for wearables and light wearables. The only difference is that we have to make use of the Wear engine for light wearables specifically, because we could see that there are two different versions. So there's one for wearables and one for smart wearables. So one for light wearables and one for normal wearables. And one last thing is we actually have different types of light wearables. We have light wearables with a round screen. We have light wearables with a square screen. And it might be that you want to make use of different modules for each of these light wearable devices, because the layout may be very different for the square screen. If that's the case, you can actually go ahead and create yet another light module. So maybe you will call it light square entry or something like that. But when you actually build your app to release it on the Huawei App Gallery, what you will do is you will go to Build Apps. And what this Build App does, it builds all the different apps, which are the files that can be installed on the wearable watches. But it then bundles the different apps into yet another file, which is called an app file. And this app file is what you will actually upload to the app gallery. But when you have multiple modules for a light wearable, you need to somehow tell Huawei App Gallery how to distribute these different modules, because some watches are supposed to get the one app file and the others are supposed to get the other app file. And for this, we actually have one attribute on the config.json called distro filter. So this way we can define which devices should get this particular app. So for example, we can define screen value, say that we want to include devices whose screen shape is a circle. So this way, this particular module will only be distributed to light wearables with a round screen. And if we want to develop a separate module for wearables with a square screen, then we will define a different module and change this value to a rectangle for those screens. We can see that the build has finished and we have an app file. And you can actually see that's basically a zip file with the different apps. So this is the app that will be distributed to smart wearables, and this is the app that will be distributed to light wearables. Right, and that's actually pretty much all I have to tell about this demo and how to develop for Huawei wearables and how to make use of the Wear engine to exchange messages between wearables and watches. Actually, one last thing I forgot to mention is that how you can install an app on a light wearable, because as we have seen when we were installing an app for the wearable, we were just able to just connect the wearable to our laptop by connecting to the same network, to the same Wi-Fi network, and using the IP address to connect to the wearable. But our light wearables, they actually do not have any Wi-Fi functionality, and they only rely on Bluetooth. So the way we would install a light wearable app on a light wearable is a little bit different. Or the way is we actually built a app file for it, and then we have to open the terminal. Well, actually, we have to somehow put this file onto our phone. So, for example, we can use ADB push, and then we have to push it to SD card /apps. So to this folder, and we can give it any name like test.app. Right, and we need to specifically say which device we are trying to push it to. So this is our phone. Yes. Then we can push it to our phone that is connected with our light wearable. Push. Right. So it has pushed this light wearable app file to our phone. So let's see what we do on our phone. So first of all, we connect to the light wearable. And then the file is on our phone. And in order to install it on our light wearable, we actually go to the Huawei App Gallery, which is where we install apps for our Huawei phone. And we search for the Dev Eco Assistant app. So this Dev Eco Assistant, it's an Android app that is used to install apps on a light wearable. I have already installed it, so I will open it. And we can see that we are indeed connected to the right watch, the GT3. And this is also how we would actually get the logs from a light wearable. So if we are using console.log, we will see it on our phone app. But when we want to install the app, we go to the app section, we find our app, we click on install, and it's actually sending the app using Bluetooth to the light wearable, and then the light wearable is sending a response back to indicate if the installation has been successful or not. And that's then how we can run the app on a light wearable like the GT3. Yeah, so that's one more difference between light wearables and wearables. But that is all I have to tell about wearable and light wearable development, and how we can make use of the sensors on the watches, and how we can make use of the Wear engine to exchange data between the wearable and the light wearable. So are there any questions?
Thank you, Mohammed, for this fantastic. If there's any questions, please just write them on the comment section, or maybe you can also pick them through the microphone.
Yes, please.
I may have some questions to start with, Mohammed. It's about real time. So as we have just demonstrated, we can access through plugin tool to this data that sensors can access. But what about accessing the same data through, let's say, HTTP? Is it something that you have tried, and is it possible? Like, I mean, real time, and also data through the cloud, let's say.
Mm-hmm. So accessing the sensor data through HTTP, did I understand that correctly?
Yeah, exactly. Like from a web page, real time.
Right. That's a very good question. Maybe I'll share my screen once again. So the real-time data you cannot access through HTTPS or anything like that, because we are not uploading it to the cloud in real time, I believe. But there is a way to get that kind of data in an Android app or from the server with the REST API, and that is with our health kit. So if we go to our documentation here, we can find the health kit. I also want to show that in my app on my phone. So you can see here I'm in the Huawei Health app, and you can see it collects a lot of data. So some of the data comes from the wearable that's connected with my phone, like the heart rate data. You can see there's quite a lot of data here, and also activities and things like that. So I have actually configured my phone to sync the data from Huawei Health to HealthKit. So you can see it's enabled right here. So the data collected by Huawei Health is also synced to the HealthKit. And so this means that I can make use of the HealthKit. You can see that it's supported on a lot of different platforms, Android, iOS, web. So, REST API, also Harmony OS, etc. So using the HealthKit, I'm actually able to obtain this data that's being collected by Huawei Health from basically any place. So for example, we can go to REST here, HealthKit, getting started. And then we see how we can apply for the permissions on the console, things like that. So also defining which which types of data we actually want to read. Of course, I mean, some types of data, they are quite sensitive, like heart rate data. It's quite private. So if you apply for those permissions, you really need to kind of explain why you want these permissions, who will be using the app, and things like that, just to protect user privacy. But after you are approved, you can basically follow the documentation to see which kinds of requests you can send to obtain which kinds of data. So let's see, for example, heart rate, we are apparently able to get it with the REST API just by sending HTTP request to this URL. But I believe it won't be in real time. No, you can see that the timeliness is in hours. So the heart rate will be collected by the wearable. It will be sent to Huawei Health. Huawei Health will update it to HealthKit. But this process will take a couple of hours, perhaps, in some cases. So you are able to query this data, even though it's not in real time, but you are able to get it. So you could build maybe a website where users can display the heart rate data from Huawei HealthKit.
Okay, all right. Okay, thank you so much. I may have another questions. Actually, I had a question about the usage of light wearables versus smart wearables, but you have just actually answered that in during your demo. So actually, you have to install Deveco on the phone, on the smartphone, to be able to upload and to access the light wearable data.
Right. I almost forgot to mention that, but that's an important difference. Yes.
And it doesn't have an IP address like a smart wearable, right?
No. And I have to admit that makes the development process a little less smooth, because you're not able to see the logs directly within your IDE. You're not just able to click one button to launch the app on a real device. So you need to first build it, then you need to copy the file to your phone, and then use an app on your phone to send the file to your light wearable, and it's sent with Bluetooth. So if you have a bit of a large app, it will take some time. It's not as fast as sending it over a network. So yeah, that's the process, but that's just how light wearables are.
Yeah. I have another question about maybe the architecture. So as you say, the Harmony OS is maybe a cross brand OS, cross infrastructures. So does it mean that it will work in any brand like Samsung, Xiaomi, etc.?
No. The vendor have to adapt. They implement it on the hardware. So this is what we're trying to do now in China. Basically, we're trying to talk with all the vendors of IoT devices and ask them, if they want to join Harmony OS and use the Harmony OS system to enlarge our ecosystem. Yeah. But if Samsung, they have their own operation system, so that's why it won't work with Samsung in this case. Yeah.
Okay, so let's say in a normal usage, a developer cannot use Harmony. I mean, if the iOS is will not allow to install something else. Huh?
No. So iOS have their own operation system. Yeah.
Okay. I may have another, maybe a last question for Mohammed, because you've mentioned the fingerprint. So how do you generate this fingerprint to communicate with the wearable?
Right.
Maybe I was not very attentive to that point.
No, I actually did mention it. You're right about that. It's a bit of a long process. I will try to see if I can find the documentation for it. Yeah, it is actually quite a bit of a long process. So let me see if I can find the documentation. release. So it's a little bit different. I mean, of course, the principle is the same as with app signing in any other platform, which is to make sure your app is genuine and others cannot install an app on your behalf and things like that. But the process is still a little bit different than how it is with Android. So let me see about projects and apps. Not here. Well, okay, let me just show it in the IDE. So the way it works is you define the signature in your build.gradle file, which is of course similar, but you have to do a couple of things. So you need to get you need to generate a profile, and you need to generate a store file, and I believe it was somewhere from here. Let me see. Tools, codes. But it should be somewhere here. Wow. Cool. Oh, right here, generate key and CSR. So you generate a key, you fill in the password, things like that. You continue, and it will give you a CSR file. So this is a certificate request file, and then you need to go to the console of Huawei and log in with your developer account, things like that, and then you have to upload this certificate request file to the App Gallery Connect in order to get a certificate which you can actually use to sign your app. So there are a couple of more steps involved over here. So you go to certificate management, you click on new certificate, and you upload the certificate request file here. And then you get a certificate, either a debug certificate or a release certificate. So if you want to release your app, you of course need a release certificate. And after getting the certificate and after adding your device here, so you also have to add your device here. So you can say My Watch 3, for example, select the smartwatch, fill in the UDID. The way you get the UDID is actually with the HTC command. There is documentation about this, but I don't think I could find it right now, so I will try to just show it. So you have to go to the folder where the Harmony OS SDK has been downloaded. So in my case, it's right here. Let me navigate to there. Let's see. It's a bit slow. See users. So we can see there is a folder here with tool chains. So you could, and here is a file called HDC. So this is our debug bridge. So you could add this folder to your path so that you can call it from anywhere. But if you have not done so, you just open the command prompt at this location. Laptop's a bit slow. Then you're just able to say HTC shell VM-U, I think. And of course, you need to connect your watch because my connection has dropped again. So for that, you say HTC TCON, fill in the IP address of your watch. And then you can, so the help output help me to figure it out. You can write HTC shell VM get -UDID. So you get the UDID of your watch. So you copy this value, put it in here, and then you have basically added your device to the console. you have generated a certificate with the certificate file, and then you can head over to your projects and scroll down to have provision file. And then you can make use of the certificate that you had created and select the device that you have added here. And then you will actually be able to get a provision file, which is also needed to sign the app. So it's very involved process. From the IDE, you get the certificate signing request file. With that, you get the certificate file, which you add here. From the first step, you also get the store file, and then at the last step, you get the provision file, which you get from here. And with all these 3 files and your passwords, etc., you're finally able to sign your app. But the good news is, if you are developing for Watch 3 for a smart wearable and you connect the watch, there's actually an easier way to do it. Not sure where it is, but you can basically create a debug sign key just with 1 button click if you're developing for a smart wearable and you have already created the app on the console. But yeah, this is what you definitely need to go through if you want to release an app.
Okay, thank you so much, Mohammed. Maybe it's for sure the good way to be sure that we are developing in a secured environment, as usually there are sensitive data involved.
Right, exactly.
If there is no other questions, we may end this session. Well, it's have been a great morning and very, very interesting information about wearables and specifically Harmony OS. Thank you all of you, all of the speakers, Mohammed, Yan Liu, and Minky. Maybe the other speakers that haven't been able to join us or to talk. Thank you all the participants, and I hope to see you again and maybe another seminar online, or I hope also offline. Thank you all of you, and I wish a happy weekend for you, all of us.
Yeah, thank you everyone. Also, thanks to my colleague Mohammed for the demonstration of coding and demo apps. Have a nice weekend.
Bye.
Thank you. Bye-bye. Bye.
Thank you. Bye-bye. Have a nice weekend.
Thank you. Bye.
Bye.